Hey everybody. How we doing? So while preparing for this talk, I dug deep into some of the history of React and found some old meeting notes from 2015 and 2016. Ten years ago, we started an ambitious project to rewrite the entire architecture of React to support incremental rendering. The team knew it was important and had conviction that it was the right direction, but there were a lot of ideas and opinions about what it would look like, and we had to understand it for ourselves. We also knew that there was a risk that it would be hard to understand. This is an entirely new model with APIs that weren't invented yet. So in 2017, Sebastian shared a vision for where React was going. He had visions for where we needed to go to innovate React, and even though we didn't know exactly what it would look like or how we would get there, we needed to enter the innovation window. So if you don't know, the innovation window is a term from research into how innovation happens. Every innovation tends to follow this trend where a previous idea hits a local maximum of maturity, and then it's replaced by a new idea, which necessarily takes one step back before hitting a new maximum. Sometimes this works in the case of cassettes moving to CDs, sometimes it doesn't, such as Betamax or Minidisc. See, when you invent something, the expectation from people on the outside is that it progresses linearly from the idea to the solution. But in practice, real innovation doesn't work that way. Real innovation is messy, because you don't know exactly where you're going or how you'll get there. The time between 2017 and today was messy. It wasn't clear what we were working on or how we were going to use it. And the truth is, you didn't understand it because we didn't understand it, not fully. But we knew we were onto something, and we continued pushing ahead, solving one problem at a time. We announced hooks to make it easier to write async components, but it introduced rules that were sometimes hard to understand, like use memo and use callback, that were annoying to use. But we knew we could solve those problems in the future with a sufficiently advanced compiler, which we have now. Then we shipped concurrent rendering as an opt-in with APIs like start transition and use deferred value. But those were hard to understand and use without a suspense-enabled data fetching library, whatever that means. But this was an important milestone because it meant users didn't need to rewrite their entire app. Last year we shipped use to support spending on data and improvements to transitions by supporting async requests, and use optimistic to make it easier to show user feedback. And today we announced activity and view transitions to deprioritize hidden content, first-class support for animations integrated into the scheduling features that we've built. This means that today, we've shipped everything that we promised in 2017, and we're kind of out of the messy part. As a team, we know how these features work and what the next evolution of React is going to look like. But using all these features is still hard to understand. Users are still in the messy part. Users don't understand how transitions work or how they relate to suspense or optimistic updates or server components, and it's not clear how all these features work. Often what I hear is transitions are a one-off feature for improving some performance issue with rendering. It's probably because of all of our time slicing demos. But these features like transitions are not one-off APIs to solve a specific performance problem. They're a completely new structure for your app to support asynchronous by default. In fact, Dan's talk about time slicing, before we called these features concurrent, we called them Async React, because they're primarily about handling and building responsive asynchronous apps. So today I want to reintroduce these features and show you how to use everything that we have in React today to build responsive asynchronous apps. I'm Rick Hanlon, and my talk is Async React. No React talk is complete without a UI's F a state or a drink. So we've talked about UI as a function of state a lot, and this makes a ton of sense for synchronous updates. You have an event, schedule an update, which computes the new state, and then you render that update with a function to give you an output, and then you commit that output to the UI. But what happens if you add async? Well, you have an event, and then there's some network time in between, and then you have the update, and you figure out your new state, and then you have some more network, and then you render it, and then you have some more network, and then you show it on screen. So what do you do in the in-between state? Well, we can take a look at HTML. Just use the platform, right? Well, if you, in raw HTML, you click a button, nothing happens. Document loads in, it's blank. And then finally, as the document gets processed, top down, it reveals the content. So by default, HTML will give you one state. You get nothing on the button, you get nothing in between, but you do get the result. JavaScript was invented to solve this problem. JavaScript allows us to add some interactive code to update the button. Let's see what that looks like. You click the button, you get a nice little spinner, but you still get the flash of content. So this is an improvement. Now we have some busy indication, but we still have nothing on that page load because we're using a multi-page navigation and the browser works the way the browser works. Client-side libraries were invented to solve this problem. So let's do some signals. Or any client-side library would work the same. So we click login, and we get a lot of spinners. So we have a busy state, and we have a done state, and now in between, we get a lot of loading states. What are we doing? We started with too little feedback, and now we have too much feedback. And our core insight back in 2017 is that this is not a performance problem. In the example that I just gave, we were updating the page as fast as possible. But it wasn't coordinated, because this is a coordination problem. So if we kind of take a step back and think about, for these 3 steps, what is the ideal loading sequence? And I claim that you should focus on 3 panes. When the user interacts with something, you should show an immediate busy indicator. Then when the content is loading, you show a loading indicator. And then when it's done, you show the content potentially animating to it. So this is what an ideal loading state would look like. You get a loading indicator on the button while you're making the post to log in. And then once that's finished, you begin loading the content and show the user a nice shell of the app that they can interact with and use features like streaming to stream in content as it loads. But fundamentally, it's a single loading experience. And then you have your done state that you can animate to. So how do we do this? How do we get rid of all these intermediate loading states? We think we had a solution that we've been building for a while. We call it Async React. Async React is async by default. So one of the key insights is that by structuring your app so that everything is async, then you're able to handle fast network and slow network. So when the network is slow, you have the nice loading states, but if it's fast, you shouldn't have any loading states. That's an entirely new way to structure your app that is asynchronous by default. Okay, but how do we do it? You want to see a demo? Okay, can everybody see? Okay, so here we have our login page. And we're doing what we were doing in the last example of setting pending true, and then we log in, we set it to false, and then we navigate to the page. And that gives us this experience. Do you see the flash of content there? That's not great. So let's fix it using React features. So we can remove this pending state, and we can do a start transition. And let's see what we got. Sweet.
Ricky, can you bump up your text?
Yep.
Thank you. Beautiful. Perfect.
Oh, we didn't use our pending state. We can get rid of this now. Yeah, that was the problem. I already imported it. So now we have a transition for our login button, but we're still getting that flash of state. So on our home page, we're fetching data in an effect. So on initial page load, we set some state, and then we fetch it in an effect. And you couldn't see it before, but there was actually still a flash of nothing. So let's convert this to use suspense. We can move this up here. And instead of our effect doing this, we can do lessons promise. And set. And I'll deal with this later. Well, we can just do it. What'd I break? Lessons is not defined. Oh, yeah. Yeah. This is kind of the point of the talk, isn't it? So, point is, these APIs are hard to use out of the box. So what if we did it differently? What if we added some of these async features into our router? Well, then we could just get rid of this. It's the wrong get lessons. That explains why it didn't work. Don't need this. Might need that. Now when we go from the login page to the main page, it instantly goes to the content. So I could have implemented this without a data fetching library, but it's kind of hard to do that today. And that's because it's kind of a hard problem to solve. It's very complicated to implement async into your application. So you really want to reach for something that does something like caching. But what we have in this case is the login button holds back the content until the list is ready. Which is nice, but it can create some delays because now the user can't interact with the shell of the app. You don't have the loading states as they come in. So we can fix this with a suspense boundary. My data was still cached. There you go. So now you get a suspense boundary. And let's say we want to add some animations. Come in. That didn't work. Oh, animation's true, huh? Now when you log in, you get this nice crossfade animation. Oh, I have 1 minute left. It's not going to be enough time. All right, let's skip ahead to some things. Let's handle the on-complete. So we have this issue where when I click complete, well, it's going to look nice because I turned on transitions. Let's undo it all. So in a synchronous app, when we check these done, let me do that again. We got these 3 items here that are incomplete. If we go to in progress, we can see they're incomplete. And if I check them done, and then navigate to complete fast enough, you get these janky paints. So I'll mark all these incomplete. What? That's not my mistake. This one is not my mistake. The issue is that coordinating all of the data mutations in the UI updating requires a bunch of work. So you could imagine fixing this with like a use effect. It's like, oh, when this is done, then in this change, set some state in an effect, fire the effect to refetch the list. But you shouldn't have to do any of that. Let's fix this problem with modern features. Sweet. So we'll go back to let's just refactor this whole app. We're out of time to use the new stuff. Okay, and then in handle complete, make sure this is still working. So if we just go back to where we were with use, we get this loading state, but what we really want to do is update the complete in a transition. We want async by default. Let's do a router.refresh here. Now we get a glimmer state on the tab, and it holds it back until the items are complete, and then you get a smooth animation into the list. Let's see that again. And let's, yeah. 1, 2, 3, complete. Go to the complete list. We see everything's complete, and we can mark a couple here. It's complete. Go to in progress. And it's just coordinated. But let's see. Okay. But let's see if we speed our network up, what the experience looks like. It just feels instant. So it's automatically scaling. I get told I have to wrap up, but I think one of the key points here, and you saw me kind of like struggling with it, right, is that like writing all of these individual features is kind of a pain in the ass, if I'm honest. So how do we solve this problem? What is the next phase of React? We have all these moving parts. How do we make it really easy? And I claim that if we integrate the async by default into our router, data fetching, and design components, then everything gets a lot easier. So for example,
All right, Ricky, thank you so much. Everyone give Ricky a huge round of applause. Live demos are wicked hard.
Yeah.
Great job, Rick. So yesterday we did have a scheduling issue that prevented Rick from finishing his talk, and that is no fun. We did not want to leave it on that note. So we want to thank Rick for his grace in handling that situation, and also for your patience. Overwhelmingly, everyone has come up to me and be like, how does it end? How does it end? How do we get the rest of Rick's talk? So I think Rick put it best when he said, my talk is just suspended. I'll be finishing the rest of it tomorrow. So here to give the epic resolution to Async React, please welcome back to the stage, Rick Hanlon.
Where was I? All right. Demo time. Okay, can everybody see my screen? Okay, font's good? Perfect. How's that? Okay, so we have a little demo app here. It's a to-do app with a React course. And in the app, you can check off some items. 1, 2, 3. Right now, there's no network lag, so everything's synchronous and it works great. This app is written in like React 16 features where you're fetching in a use effect. So I would call this like a synchronous React. You're not using any of the new async stuff. So you get the home tab here. We have some query params with searches and tabs. You have a use effect that fetches whenever those change. And we have a couple of callbacks here for when the search changes, we update the router. When a tab changes, we update the router. Pretty simple stuff. So what's the problem with this app? The problem with this app, and I built a little network debugger here down at the bottom. The problem is if we start slowing down network, we're going to start seeing some janky experiences. Oh, what happened? Did you see that? Let me check these off again. 1, 2, 3. So they checked, and then they cleared, and then it refetches, and then it pops back in. That's not great. What other kind of problems can we find? So let's say I check off some of these. Let's check them all off. And then we go to the In Progress tab. Yeah, this is not working very good for us. Let's try the complete. Let's say check some of these off and then go to the complete tab. Yeah, it's pretty janky. So how do we fix these features with modern React? Well, let's start with the complete button. So we've heard about these things called transitions. And we're kind of manually managing our transition state here. What if we did this with one of these new features? So we can change this is pending to a start transition. Great. And start transition provides a pending state for us. So we can move the complete into the transition, delete this. And now we don't have to manage the pending state ourselves, which is nice. But let's see how it performs. So now let's click one of these. Oh, kind of has the same experience. So as I mentioned earlier in my talk, these are not one-off features where you can just drop them in somewhere and they just work for that one specific use case. This is an entire re-architecture of how you think about building your apps by building them async first. So the problem here is we added start transition, but it still performs the same as before, because fundamentally the issue is here in our use effect. We're not fetching the data until after we've already committed the results to the screen. Once we've committed the results of the completed state to the screen, then we fetch to get the new data. And you can solve this with a lot of different techniques, when like doing a client-side cache and using a store, and when it updates, you update your client cache. But that has problems in terms of maybe you have different tabs open, or there's different users changing the data. And that's why you'll end up hitting a lot of cases where you have conflicts with the server and the data that's actually in the database. So it's actually best to refetch everything from the server, but if you're going to refetch everything from the server, you need something to coordinate it for you. So let's replace this effect. And let's do that with suspense. So I'm going to do a little caching for promises. If anybody's familiar with use, you got to cache your promises. And that means we can delete some of this code. Let's delete this effect. Don't need that anymore. Let's update our revalidate function to clear the cache whenever we revalidate, and then when we update, we'll need to do that in a transition, just so that it's combined with any other transitions that we have. And our app's going to be broken for a minute. And then we can go to our lesson list. And now we don't have our lessons, because we deleted it from above, but we can just use those. And now we don't need this fallback here. We can delete this. We can use suspense for our fallback. See if I missed anything. I did miss this. Got to delete that. All right, so now we have this nice loading state with suspense. And you know what, while we're here, let's also add an animation. Let's get crazy. I heard this view transition API is pretty dope, and I can just do one line, right? Oh, that's really nice. It's pretty sick. All right, so now how is our transition working for the checking done? Let's try it. Nice. Mark these 3 done, it waits, it refetches, and then they fade in all at the same time. And there's been some controversy with the batching behavior in React, but one of the things that you can see in this example is that, and if I slow this down a little bit so we can run it a little bit more often, is that when you're doing animations, it's actually really nice to be able to do the animation all together rather than staggering the animations just because you want to try to do it as fast as you can. Because especially when you're using the view transition API, the view transition API in the browser doesn't allow you to run 2 view transitions in parallel. So if you try to do it as fast as possible, you'll end up delaying it in sequence. So if you have a 200 millisecond animation, it'll take 600 milliseconds to run each of those animations in sequence. So this is really nice and really optimized. What about the problem that we were seeing earlier, where I check something done and then I go to the complete tab? Did we fix that? I don't think so. Let me change some of these settings. Let's say our mutation takes a while, but our fetch is really fast. Maybe we're going in and out of a subway and we got spotty network, and or the server's taking longer for mutations than it is for fetches because the fetches are cached. If we do that, then we can uncheck a bunch of these and then go to in progress. One immediate problem is that when I switch to the in progress tab, we see the suspense fallbacks. And we can fix that with a transition. So let's go to our tab change, and when the tab changes, let's do a start transition. So now when we change these tabs, those will happen in a transition in the background. We'll uncheck these, go to all. So let's see if we fix this problem yet, where when we check something off and go to another tab, we don't see the results, and then they pop in. Go to 1, 2, 3, go to complete. All right, that's pretty good. 1, 2, 3, we'll go back. I'll show it one more time because it might be subtle and hard to notice, but when I click the items and check them off, you'll notice at the bottom the network for the mutations are happening, and then the UI doesn't update until the last fetch happens, and that allows you to go to the complete tab all at once with the items that you've already checked completed with. So check, 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 and then switch, and it waits. I missed one of those clicks. It waits and then it updates it. But this still isn't a great experience. Did anybody notice that the tab, when I selected it, didn't change? So this is kind of a foot gun with transitions, is that since the update to the tab state is in a transition, it's not going to commit until everything else commits. All right, let's fix that. So we can fix that with a new API called useOptimistic. So let's do const So for useOptimistic, you pass in the actual value, which is the current tab, and then it gives you an optimistic value. That is the value that's rendered while the transition is in progress. Here we can do set optimistic to the value. And then, since we want the tab to update immediately, we go to the tab here, we set the optimistic tab. Okay. And now, when we change tabs, let me slow this down. Now when we change tabs, we get immediate feedback on which tab is selected, but it still will wait and suspend when we change to the tab. But we're not showing any pending state. One of the things about optimistic updates that are interesting is that if I change to the in progress tab quick enough here, this is showing just the results. But that wasn't the in progress tab. Sometime later, the in progress tab comes in and flips it, which is not a great experience. So you want to be able to show some kind of pending state, even when you're using optimistic updates. And that's not always the case. So for like an Instagram like, where you can kind of just hack it and the user doesn't really need to know that something in the background is happening, like it's not confusing if they don't know that, it's fine. But in this case, if I click on the complete tab, that's cached, so it didn't work. If I click on the complete tab, then if there's no feedback that something in the background is happening, that's not great. So we can solve that. We have this tab list component has a is pending. Tab equals, when the tab is not equal to the optimistic tab, we can show a pending state. And now when we change tabs, we get this nice like glimmer effect that lets you know that that tab is loading in. Cool. We're adding a lot of code for all of this, all these features. There's one more thing that we want to do. Because if you noticed in the code here, our search is not using transitions. So what's that going to look like? Well, if I search here, we get this forced fallback state, which for transitions or for suspense, if a suspense boundary is updated synchronously and suspend synchronously, it forces the fallback. But while we're typing into the search bar, we still want to be able to see something. Like I was looking at a list. Why would you completely hide it and cover it up? So we can fix that again with transitions. So let's do a start transition just around here. Oh, I need to also pass our tab. Yeah, see, these transition APIs are hard to use. Let's go in and add optimistic state for our search. Because one of the things the thing that's happening here is since we updated the search in a transition, now we lose the immediate typing because the search field is controlled by the URL param. So as I type here, I can't type anymore. You can't see it, but I'm typing and nothing happens. And then at the end, it'll go through. And so we have to solve this in some way. And we're going to solve it by updating the search bar optimistically, the search input. And I need to pass our current optimistic values whenever we change the params. And then finally, I will need to do the search, optimistic search into our search bar. Let's go ahead and add our pending state. And let's see how we're doing now. So here we can search for suspense. We get this nice glimmer state and a loading indicator while it's loading. No results because I spelled suspense wrong. But we can go back and we see suspense. So this is a great experience, but this code is like hard. It's like, it was even hard for me. I was talking to somebody and they were like, you're gonna do this like live? Doing all these features live is like stressful. And trust me, it is. It is like, is this the future of React? Is this what they spent 10 years building? No. So I'm going to show you what this is going to look like in the next few years. Let's say instead of implementing all of this ourselves, we implement our own data fetching library. And we implement a suspense-enabled router. These are the two layers on the outside of your product code, right? So the router is going to take all of your, inside of your event handlers, you're going to tell the router to do something. So that's on the outside of your product code. And the data fetching, when you first load, you're going to fetch things into your product code. So if let's make those layers use Async React and use these features out of the box. And then let's do one other thing. Let's have our design components use action props by default and build all these features of optimistic updates and transitions and all these async features into the design component layer. Because again, in our product code, we don't want to have to write all those things. We just want it to work as async by default and all the immediate feedback working. So what does that look like? Well, I'm going to just like delete a ton of code. And the way I'm going to do that is by doing action props. So here, let's do action. So if you're not familiar, action props are a pattern that we introduced in React 19 that calls your callback inside of start transition already. So you can do things like await mutations or navigate, and all the transition and the async stuff is already handled under the hood. So that means that we can, and we use a action suffix to indicate that it's inside of an action, so you know it's async, and so you know it's inside of a transition. So let's do complete action. So since we know this is inside of a transition, we don't need this start transition. And since this is using an action prop, this button component should already handle its own loading state. So we don't need to handle it. We can just delete all of that. And now let's see what else we can delete. Let's delete our suspense. Our data fetching layer already handles suspense by default, so we don't need to suspend ourselves. Let's do data.getLessons here. And then on our revalidate, we can do revalidate. Oh, and I'm going to have a syntax error if I don't fix this, or a import error if I don't delete that import. Where were we? Perfect. And now we have all these optimistic updates. We can delete those. We have these transitions. We can delete those and rename this to search action. Don't need that. And our router doesn't need us to do this anymore because it's suspense enabled. Tab change, so let's rename this to tab action. And let's delete this, and this, and this. And now we can just pass our search value. We don't need to pass an optimistic value. We don't need a pending. We just need a change action prop. And same thing here, we can just pass our tab. We don't need an is pending. And we just need a change action prop. And let's see if we have the same experience as before. Let's slow this down a little bit. I missed one. Give me 1 second. Oh, up? Oh, which one? Oh, I see. No, that's right. Oh, I hit this earlier. Well, fortunately, I have a backup. I know what it was. No, I don't. So this should have the same experience as before. I don't know why my completes aren't working. But I'll figure that out later. So the point of this demo is that with all of the code that we wrote before, with all the manual use optimistics and all of the manual start transitions, you can build the same experience as before without my bug. Huh? Oh. Yep, that was it. Thank you. Yeah, I'll post the code later. All right. So the point here is that with this little amount of code, you just declaratively say in your search action, set the params, and then change action, set the params. You're not writing all of the async features yourself. You put these layers you put those features into the other layers, the design components, the router, and the data fetching, and then you can just write your code with what you want it to do, and everything gets coordinated for you automatically, which is better for humans, but it's also going to be better for AI. So that's the demo. So, we started a while ago. This is Async React. And we've seen what's possible with Async React. We can write our code without thinking about whether it's sync or async. And React will automatically optimize it to a great user experience. At the core of Async React is transitions. Transitions coordinate all of the async React features into smooth loading sequences. Inside a transition, use optimistic allows you to give immediate feedback to the user that's local to their interaction. Suspense allows you to provide a loading state when new content loads in. And view transitions allow you to animate the final result. Using these features provides an intentionally designed, optimal loading experience without flickering or things popping in randomly. But as network speeds up, your app can automatically perform as if it's synchronous without loading states. This is the vision for the future of React. The vision's not complicated. The vision is not that it's complicated or hard to understand or requires a PhD in React. It's simple declarative code that just works. We've taken one step backwards, and it's been messy, but we're ready to take 2 steps forward. So how are we going to do it? We need 3 things. We need async support in our design component libraries with action props by default, optimistic updates by default, and new design patterns for loading states while work happens in the background. We need our routers to support async by default, which means using transitions by default and activity configs for rendering different apps, different routes in the background, and transition types for standard route navigation animations. And we need our data fetching libraries to support Async React by default. And that means suspending by default and providing options for preloading by default so you can have faster loads and patterns for refetching. So what are we going to do? Well, we're going to start a new working group it's called the Async React Working Group. In this working group, we want to help support the community in understanding these patterns and how to roll them out in routers, data libraries, and design components, And we also want to work with educators and folks that are teaching the community to how to explain these patterns and how to build them into their app. Finally, I just want to say thank you to everyone who's worked on all these features over the years. I especially want to say thank you to Seb. Seb, you started on this journey 10 years ago, and it hasn't always been easy, and it's been messy, but you're an inspiration to all of us, and we thank you all for everything you've done. Thank you.
Shooting for the stars.